Welcome DevOps guys to this video. In this video I'm trying to simulate or mimic the behavior of one of the most well-known platforms, which is Kirakoda. Kirakoda gives the opportunity to students to play with tools, DevOps tools like Kubernetes, Docker, Argo CD, etc. So in Kirakoda playgrounds you will have multiple environments. If you ask for Kubernetes cluster, here you click here, and then Kirakoda will hand you over environment of Kubernetes cluster that contains normally 2 nodes, as it was in the title: kube control, get node, and here you have the master node and the worker node, and the environment or the infrastructure behind the scene will be destroyed after 60 minutes. So to realize such an environment, one of the ideas that can work here is to have a pipeline behind the scene that deploy the infrastructure and destroy it after 60 minutes. So I'll show you the diagram that I did. So here, this is me, the owner of the labs. The labs will be destroyed. The ephemeral or the temporary lab will be deployed in AWS, and I'm using GCP as my managing infrastructure, managing cloud. This is where I deploy the tools that controls my labs. And then I have two configuration of Terraform. And the first configuration I'm going to deploy, I'm going to do an apply with Terraform. On the first configuration, this will deploy Kubernetes cluster, which is GKE. And then inside it, I'm applying the second Terraform configuration files that contains the GitLab stack. GitLab stack comes with Prometheus, CI/CD, GitLab repo, and many other components. And I'm deploying also Prometheus, and I'm deploying also Grafana, and connecting Prometheus to Grafana. Prometheus comes with GitLab stack, and I'm leveraging the ingress that comes with GitLab to split the traffic between all the tiers between GitLab and Grafana and the other component inside GitLab. And GCP will deploy a load balancer for me. In parallel, I'm deploying also S3 bucket, a combo of S3 bucket and DynamoDB. This combo will work as my remote bucket for my future pipeline. And then I'm going to push the Terraform files that contains the configuration for my lab, ephemeral lab or temporary lab. I'm going to push them to the GitLab repo. Then when there is a user, he asks the front end for a lab. I'm not going to simulate the behavior of the front end. I'm going to run the pipeline myself. Normally the front end will kick off the CI/CD, the pipeline CI/CD, then CI/CD will consume the Terraform files that are inside the repo and deploy them on AWS, since all of them have only one provider, which is AWS, and communicate with the AWS API and deploy my lab, which is an EKS cluster, starting with deploying the VPC and then subnets, node groups, security groups, knuckles, etc. to format the Amazon EKS. After that, it will push the Terraform TF state to the S3 bucket. And then the access will be handed over to the user, like Kirakoda, and times start kicking here. When time is up, the second job, which is Terraform destroy auto proof, will be triggered here, and the CI/CD will destroy the infrastructure using Terraform destroy. So this is the idea of this video. I'm using also Slack integration with GitLab CI to push some notification whenever there is an apply or a destroy. So let's go into action. You will find the GitHub repo in the description of this video. I have 2 repos, one that leverages the DNS Google CA. You should have a DNS name or DNS domain name for your GitLab and for your load balancer after the deploy. If you don't own that, you can use one of the wildcard DNS, free DNS, which is the nip.io or sslib.io. But here you have some limitations, since the sslib.io have a quota of 10,000 certificates per week, I think. If Let's Encrypt, because the CA for this lab is the Let's Encrypt. Let's Encrypt is a free CA. It can sign 10,000 certificates for sslib.io per week. Beyond that, you cannot get signature on your certificates. That's why I balanced over to the Google CA. And of course you have to own a DNS name. I bought one for I think 60 cents. Anyway, for this lab we have some requirements: GCP account, of course, AWS account, and AWS and GCloud CLIs needed to be installed and configured. So the first thing we need to do is, of course, to copy or to clone the repo. I had already done that because it was already in my computer, and here I am using an Ubuntu environment. So when you clone the repo, we have 3 folders. The first one is the infra. The infra is responsible for deploying the Kubernetes cluster. Inside the infra, we are deploying, first we are enabling some APIs, compute API, container API, and then create service account for Terraform and give it some roles, some permissions, and then we are deploying the cluster, GK cluster. This cluster is composed of 3 nodes. The size of the machines are E2 standard for CPUs, 16 gigs of RAMs. You cannot do this lab with a smaller machine, since the GitLab is hungry for resources. It has so much components, and disk size is 50 gigabytes. And this is why we need the GCloud to be installed and configured, because we are using a local exec to fetch the kubeconfig and install it on our local machines. To access the cluster after the deployment, the outputs will be the name of the cluster provider. Of course, we are using Terraform. Required provider, Google and null resources for fetching the kubeconfig. Variables are project and the region, and we should have file of our access keys. I don't know where did I put them, the access keys. Yeah, they're here, provider. Inside the file access keys.json. I'm gonna copy them and come back. So that's done. Here is my access keys. After that, we access we get inside the directory, and then Terraform. I have already initialized my environment, my Terraform backend, local backend. So Terraform says here infra. Normally I should be init. Let's redo it. And then Terraform apply. Okay. Yes. And now we meet. And the time being, I forget to say about the CA, because here I am activating or enabling the API for the CA. Yeah, this here I am enabling the API for the CA, and then creating a binding key. This will be used later by my certificate manager on my cluster issue. So see you when it's done. So that's done. My cluster has been deployed, and if I do control get node, I will get 3 nodes, you can see here. Now the next step is to deploy the stack inside the cluster, the GKE, which is the GitLab and its components, using the Helm, and deploying in parallel Grafana and configuring Grafana to connect to Prometheus, and leveraging also the ingress of the GitLab to split the traffic between all the components inside my cluster, and the GCP deploy a load balancer for my ingress. In parallel also I'm deploying an S3 bucket in DynamoDB and use that couple as a remote backend for future pipeline. It will be used by the pipeline as a remote backend. The DynamoDB here, of course, it is used to block the state. So to do that, go to the local directory, which is the temp lab here. I have here all my configuration files, starting with the main. In the main, I'm deploying first the S3. First of all, I need to grab my credentials, which are in the upper directory. They are here. And then the first thing, I'm deploying the S3 bucket, and here I'm enabling the versioning and enabling the encryption. The versioning is highly recommended when we deal with Terraform infrastructure as code, in case we want to roll back to our previous state, and the encryption is for security, server-side encryption for the S3 bucket. And I'm using here DynamoDB. I'm deploying DynamoDB to unlock the states, even though there's only me who is messing with the states. And then after that, I'm deploying the storage class, because my cluster needs to provision some persistent volumes. And here I'm deploying the GitLab namespace, preparing for the GitLab, preparing the ground for the GitLab. And here I'm setting the root password for the GitLab as a secret inside the namespace of GitLab. And then here I'm specifying my domain name as a local variable. Here, DynamoDB and more website. And of course, you can use one of the free wildcard DNS domains, but you would be limited by quota. Here, I'm using here the CI of Google, and it is unlimited. And here, this is the helm for the GitLab, and configure the helm of the GitLab TLS certificate manager. So here I am enabling the certificate manager, and at the same time I am disabling the issuer that comes with the GitLab. GitLab has an issue which is scoped at a specific namespace, which is the namespace where the GitLab is deployed. And rather than using that, I am using I'm deploying later cluster issuer, which is a cluster scoped. That means it can issue a certificate, not issue certificate. It has the configuration for the certificate for all the ingresses that are in the cluster. Wherever here issuer, it will have only the configuration for those ingresses that live inside that namespace. That's why I am disabling it. And for the certificate manager, I'm passing here annotation to use the Google CA, public CA. And here I'm specifying my domain here, the ingress class, and the secrets for the TLS for all the tiers. And I'm restricting the resources of GitLab, since GitLab is hungry for resources. Otherwise, I cannot deploy all the tiers of GitLab or the component. And restricting also the storage. Then deploying Grafana and passing the configuration for Grafana inside the YAML file. So here, passing some annotation to use the public CA of Google. And the ingress class, it would be GitLab Nginx, like the GitLab, to leverage the ingress controller of GitLab. So the ingress controller, whenever it sees this annotation, it will serve this ingress and redirect the traffic to it whenever the user asks for it. And here I am passing the connection or connecting Prometheus to Grafana. Then what else we have here? After that, I am deploying my cluster issuer, and here I am fetching the key. This key, you can think of it like an identity for the cluster issuer. So let me go back to my infra configuration here. In the infra configuration, we had provisioned this key, enabled the CA of Google. So here we are giving the authorization to my account to use the public CA, enabling the API, and then we're creating a key. This key, it is like an identity proof for the CA to tell it, here I am who I am claiming to be. And then in the other, here I am deploying here the secret. First of all, I am fetching that key and deploying it inside the secret and using the base64 MAC key. This is an attribute in this key, which is the base64 encoding for that key. And inside the cluster issuer, I'm deploying here the cluster issuer. Inside that cluster issuer is the configuration for the certificates, and especially the server. So the certificate manager, whenever it wants to issue a certificate, it will go to this CA, to the server, and it will grab that key to prove that it is me, not someone else. That's pretty much it. So I'm going to deploy it now. So Terraform, and then change directory, change the template, init. Next, apply auto approve. Deploying. It did pass the provision, the plan. Now it is deploying. As you can see, we can see one of the benefits of using the infrastructure as code, which is the parallel provisioning. Since there is no dependency between those two, the S3 packet and DynamoDB, the Terraform can deploy both of them in parallel and ask the API for both of them in parallel. So it's here, this is the S3, and it cannot deploy this and this in parallel because there is dependency here, implicit dependency. Neither with this and the others, but also there's implicit dependency. But with DynamoDB and S3 packet, there is no relation, neither implicit nor explicit. That's why it is deploying both of them in parallel. Then it passed to the namespace GitLab and the storage class. Also, there's no dependency. Grafana GitLab, no dependency till the end. Let's wait now. So it is done. Now I have my URL here. Next thing I need to do is to configure my DNS to point to the load balancer of GCP. So I will do git control get ingress, and our namespaces. I have only one namespace, which is the GitLab. Okay, and here is our load balancer. So I need to configure all those resources to point in my DNS record to point to this IP, and the ingress controller will manage the traffic for me. Here to my DNS records, the root. I didn't copy. Okay, copy and paste here. TTL time to live 1 minute. On the GitHub. Grafana. How do you do only those 4 or 3? GitLab, Grafana, EKS. Maybe I need only the GitLab. Okay, back to here. I'm gonna verify my certificates. Of course, they will be in a false state. Git control get certificates in the GitLab. I have 2 in true state. KS is in false, but I don't think that the HTTPS is working. No, doesn't hurt to try. Yeah, it's working. But the KS, I don't know why it is in a false state. Let me try again. Yes, now it is in true state. So all of my TLS are working. The HTTPS is working. Everything is fine. Now to the next step, which is pushing the repo of my CI/CD that is located inside this directory CI/CD. First, let's access to our GitLab and create a new user. Enter the password. Let's fetch it. The infra main. Let's look for devs for root. And the main is root. No, sorry, it is in the site, in the template. The second apply, not the first apply. Okay, now we have our password here. The first thing that we need to do after accessing the GitLab is to deactivate or disable the sign up for security. And then for best practices, it is better to use another account, another root user. For that, I am creating another user. It should be lab creator, and for the email, an arbitrary email, and just a valid domain, gmail.com. And because I don't have an SMTP, if I did have an SMTP, then the GitLab will send an initialization link for the password to this address mail. I don't have one. Administrator, okay. Create user, and for the password we go back and there set it. The password. Choosing a password that contains capital letter, character, special character, and some numbers, and I think it's 8 characters. Okay, it's save changes, and then we sign out and sign in with a new user. Okay. I'm gonna change the password. I'm gonna leave it as it is. Now I'm done with the password. Sign in again. Password. Now create a project. EKS lab, okay, for each user to our lab creator. Private or public doesn't matter. Okay, create projects. And now we are in track of our project. Let's add an SSH key. I have already generated SSH key, but doesn't hurt to generate another one. Let's make some room here since we don't need it anymore, I think. The editor. And now we need SSH Edit generation. Okay, generate. Okay. And I'm gonna use this. I'm gonna keep SSH path. GitLab. Okay. Override because I have already a name like that. Override. Okay. Now we are done. We need to set the configuration for the SSH configuration. You will find it here. The configuration for the SSH is here. Okay, we need to set this variable. This variable will be equal to our DNS for the GitLab, which is gitlab.developsandmode.website. Sometime after that, we do some configuration for the SSH. In short, this file will tell our SSH whenever you want to connect to this host, use this key. That's it. Otherwise, it will use the default key, which it doesn't have access to our repo. Let me check echo $GitLab -URL. That's good. Now file password. Let's check the file. I have two keys inside it. Okay, home.ssh and then config. Yeah, I have the old one. And now the last one is this. I need to remove the old one. Anyway, okay. CVI. I'm gonna remove it. You have okay, press D4. Okay, it's been removed. I'm gonna remove also this. Next second. D and capital G. Okay. I'm gonna redo my previous file. That's done. Okay. Back to our repo. Add an SSH key, and then cat /home SSH and GitLab the public. Copy the key. So repo. Now we can push to our repo using the SSH. Okay. Now we need to get inside that CI/CD. CD to CI/CD, and inside CI/CD there's another directory. Okay, now we need to do git init and git add everything and git commit initial commit. So that's it. Now we need to do git push, but before that, git remove set or add set URL origin. Set the URL of the origin. Here you copy the SSH since you are pushing through the SSH. I think I missed something here. No such remote origin. Git remote set. I think we don't need origin. Use origin when you add, maybe. Or the okay, git remote set URL and dash push dash add. Okay, I'm gonna use add origin. Origin. That's good. And now we push. Of course, first to push refs to GitLab. Okay. This is due to the protected branch feature. Let's deactivate that. Okay, repo. I forgot to do that. Protected branches. Otherwise, we need to use another branch and then ask for merge. I don't go through that. And protect branch, and that's it. SRC ref spec me does not match any. Okay, missed something about the this is the remote here, git remote dash view. Okay, EKS, GitLab. Okay. We have our commit, we have our git branch. I see where is the problem, is the master, that's the problem. Because this is a master, let's change the name, modify the name to master, to main, git branch dash m main. Now git branch, main, okay. Now we are good. Sorry. And a push. What's the problem now? Please make sure you have the correct access rights and the repository exists. Yeah, maybe the repo. Git remote view. Fetch and push. Non-host, yeah, that's because of the non-host. Okay, so sudo, we have sudo remove, and then slash home cube, and then non-host, no SSH, and then non-host. Okay, since this is directory rm-rf, now I can push. That's because I have already done this before, and the key wasn't this key, the host wasn't this host, so whenever it tries to connect to this host, it is using the old host, which is inside this host. Anyway, let's push now. Normally everything is fine now, and yes, that's a good sign. Back to our repo. Now we are good to go. Okay, you have our GitLab CI here, YAML file. You go through that YAML file. Or before that, we need to configure the webhook. I think that's the next step. Slack integration, yes, the webhook for the Slack integration. Okay.